This is another part of atomic theory. If you know that you don't know atomic theory very well, it's better you stay and follow this page. Watch this video to the end. I'm very sure you don't know the difference between these three words. So therefore, make sure you stay and let me explain what each word means. Okay, so what is isotope? I know you know that, right? So isotopes are atoms or elements that have the same atomic number. So they have the same atomic number, but what? But different mass number. So they have the same atomic number but different mass number. For example, give me one example of an isotope. One of the example of an isotope is chlorine. It's possible you have chlorine 35 and you have chlorine 37. You know chlorine is 17, right? Chlorine is number 17. They have the same atomic number but different mass number. That's just what isotope means. Let's move to isobar. Isobars are atoms or elements that have the same mass number. So they have the same mass number. Or in some cases, they can call it nucleon number. So they have the same mass number but different atomic number. But different atomic number. So it's possible that we say that isotopes and isobars are opposites because isotope is having the same atomic number, whereas isobars are having different atomic number. You get? So that's just the different. One example of isobar, can you give me that? I will give one example of an isobar, then you drop another example for me in the comment section, right? Let's do it one. So one of the example of isobar is, let me write it here. So we have, for example, we have nitrogen, and we have carbon 14. Mass number of nitrogen is 14 and is having atomic number of 7, while carbon is having atomic number of 6. So they have different atomic number but the same mass number, right? So 14. Now let's move to isotones. Pardon me to write it like this. So isotones are atoms or elements that have the same neutron number. That's just where it is different from others. Others we are using atomic number and mass number, right? But here we are more concerned about neutron number. So isotones, the same neutron number. So the same neutron number can have different atomic number, or different mass number. So the mass number can be different. Likewise, the atomic number can also be different. But one only thing that distinguishes it is the number of neutrons. So they will have the same number of neutrons. For example, can you think of one example for isotone? Make sure you drop that in the comment section. So I'm going to give one example now. One example of an isotone, example, let me write it here. Nitrogen 7, and carbon 13. You can say they have different mass number, right? And they also have different atomic number. But by the time you calculate the number of neutrons, you will notice that they have the same neutron number. 14 minus 7, that is 7, right? 13 minus 6. 13 minus 6 is also giving us 7. So they have the same neutron number, but different atomic number and different mass number. See you guys in the next part.